Hello everyone, so this will be Jonah Valance and Ben Parker. We will be presenting on optimistic versus pessimistic concurrency in SQL. Get off my database, darn kids. So let's get to it. So overview of the problem. Let's say we have a database and user 1 edits the database, changes some records, and then user 2 also comes in and edits the database and edits some of the same records. User 2 finishes their updates before user 1 and pushes the updates. So basically they have changed something without user 1's knowledge. User 1 finishes and pushes their updates after user 2. The problem with this is that user 1's updates, because they were pushed secondary, will override user 2's, and user 2's update will be lost. And that's called a phantom record because it's completely lost. No one knows that those changes were made unless you have concurrency.
Or a phantom transaction.
Or a phantom transaction can also be called that. So there are two kinds of concurrency, optimistic and pessimistic, and we're going to get a bit into what exactly those are and what that means. So starting with optimistic concurrency, let's say user 1 makes a change and so does user 2. User 2 updates the database, but then when user 1 tries to update, they are informed that updates have occurred, that user 2 made some changes, and that they are no longer able to update. They need to make a new connection, a new session, and then do their changes over and make sure that theirs do not conflict with user 2's. This basically just helps user 1 to know that user 2 has updated the table, and that way they won't be changing any information. They can communicate with the other user and find out what information really needs to be in the database and what doesn't. This can be done using timestamps, content checkers, and there are several other ways to do it, and later on we will demonstrate how to do this within ADO with Visual Studio. So on to the code examples. First we're going to start off with optimistic concurrency. If we come over here to our front end from Kuntz's examples in Visual Studio and we start running it,
We can cut that.
it's gonna take a while to load, hopefully. So if we look over here, we have form 4 dataset and optimistic concurrency. So if we click on this, we get a form that shows the employee ID and the employee name, and what we can do is change the employee name, even though it doesn't really look like there's a text box there. So we're going to change this to Jonah. Alright, now this is user 1 making changes. So then, let's say someone else comes in, pulls up another Visual Studio, user 2 now, and is going to get into the same exact scenario. So now they are also going to start their version of the client, going to the same area, and they're going to change it to Ben. And let's say user 2 finishes before user 1 and they update. Alright, so then user 1, where they change the record to Jonah, is going to try and update, and they get a concurrency violation that basically just tells them, hey, you can't do that because someone else already changed it, and you need to restart your session, disconnect and reconnect, and make sure that everything's alright. Alright, and if we were to look at the actual database, which we can right here, if we reload it, we can see that the employee name has been changed to Ben rather than Jonah. So that illustrates optimistic concurrency, where basically, yes, both users are able to edit it at the same time, but the one that is pushed first will be the one that is kept. So if we close these out, we can look at some of the code that actually does this. So I'm going to stop this, exit out of it just to clear up some processing. So now if we look at Form 4 CS, we can see that it's used with a data set, pretty similar stuff. But the main point is the main place that we're looking is in the timestamp update. It's a special data type of its own, and basically what it does is every time a user makes a change, it timestamps it and it keeps track of when that was done, so that when user 2 makes their update, it is timestamped, and because then the data can see that user 1 was making changes before user 2, and when they try and push, it's going to compare those two timestamps, and then it's going to give them a concurrency error because those timestamps don't match in the way that they should. So then it's going to tell them that it's incorrect, and you can see that in our database that that table, that row column is right here where it says employee timestamp update. So anyway, that is optimistic concurrency. And now I will pass it over to Mr. Ben Parker to talk about pessimistic concurrency.
All right, my name is Ben Parker, and I'm going to be talking about pessimistic concurrency with SQL Server. The general overview of pessimistic concurrency is that if you have one user who starts editing the database, they open a transaction and connects to the database, then the portion of the database that they are editing, be it a row or a specific table, will have a lock put on it. If a second user comes in and tries to edit the database and open a new transaction in the same portion of the database, so that same table or row within the table, then when the lock will block them out and will not allow them to process a transaction. So if we pull up our database here, in row 1, we have an employee named Ben. So let's say that I go in and start a transaction with the database, and all of our code implements pessimistic concurrency. When my transaction opens, it will connect to the database, get a copy of the table and row that I am going to be editing, and it will then disconnect from the database, but it will place a lock on the database. There are different types of isolation levels, and I'll get back to that in just a minute, but just keep in mind that the lock that's put on the database will have a certain level of isolation. So I've started my transaction. I connected to and disconnected from the database with my copy of it, and now let's say user 2, Jonah, comes in and he wants to open a transaction with the same table that I am using and try and edit a record in the same row that I have already started my transaction with. Now back to the different levels of isolation. If I have a committed level of isolation on my transaction, the lock that's put on the database, then user 2, Jonah in this case, will not even be able to access or read the table or row that I'm working with. If I have an uncommitted isolation level on the lock that I've placed on the table, then user 2 will be able to view it, but as soon as they try and take the transaction and do anything with it and put it back to the server, it will give them a concurrency violation, letting them know that the table is locked and there is already a transaction in place going on, and they will not be able to make any transactions of their own until the first one that was in progress is completed.
So that's optimistic and pessimistic concurrency. Thank you all. The boys are out.
Ciao for now.